Recording started. So, first of all, first part of motion. I usually started explaining something. So, first part of motion called kinematics. Kinematics describing motion, not looking into what caused the motion, why motion happens. So first we're looking into the describing of the motion. And to describe motion we need to introduce few physics quantities. And some of them are quite similar, so we need to get a good understanding what the difference between them. So distance and displacement. So if I, for example, for simplicity's sake, let's say my one step is 1 meter. So if we will make, let's start from here, we'll make 1, 2, 3 steps this way, then turn around and make 1 step back. What distance I've covered?
2 meters.
4 meters. I moved 3 meters that way, 1 meter back. So I've covered 4 meters. And so distance is the length of path. My length of my path was 3 meters there, 1 meter back. But how far I was from my starting point?
2 meters.
2 meters.
Oh, right.
So displacement is a change of the position. But it's not enough just say 2 meters to describe displacement. Need to be described in which direction. So in this case, from your perspective, it will be 2 meters to the left. So for displacement, you always must specify not just how big it is, but in which direction. So distance, length of path, displacement, change of the position. And we need specified direction. In this year, in Unit 1-2, we're learning only motion in a straight line. In Unit 3-4, we will be looking into the motion where the path will not be straight line, will be curved, but that will be in 3-4. This year, we're looking only if the path is straight line. Now, let's introduce 2 more quantities: speed and velocity. By the way, for both distance and displacement, we will be using letter S. We will be using in physics letter S, yes. And measured in meters.
So how do you differentiate between the two if they're both S?
Depends on the question, based on the question, what you need to find. Now, speed and velocity, both of them denoted with the letter V from velocity. And because there are 2 different things talking about the velocity. There is instantaneous velocity at that particular instance of time, can be instantaneous speed as well. Can be average. Let's start from the average speed. Average speed, average, equal total distance over total time taken. So, if, let's say, you live in, let's say, 500 meters from school, and you walk to school, and it takes, let's say, 100 seconds.
That's quick.
And took, let's be more realistic, let's say 200 seconds. So what will be the average speed?
2.5 meters a second.
We divide 500 over 200 will be equal to 2.5 meters per second. And average velocity will be the same. But let's say you're returning home and you return with the same, you're walking, you spend the same time. So you wait to school for 500 meters. Someone really lucky if live that close, 500 meters, and you walk 500 meters back, and you spend total 400 seconds. So your average speed will be still the same. We will have 1,000 meters over 400 seconds will be still 2.5 meters per second. But velocity average is displacement over time. So if you went to school and returned back home, what is your velocity? What is your displacement? Displacement 0. So what will be your average velocity?
0.
0. So you see you walked 1,000 meters and your average velocity is 0. Because you haven't changed your position, you return back. And velocity also has direction. You cannot say just velocity 10 meters per second. You need to specify in which direction. It depends on the situation. You might specify it's left, right, north, east, west, south, or something like that. Velocity has direction. Speed does not. Now, that average. If you talk about instantaneous means at this instance of time. So that will be a rate of change, velocity, instantaneous velocity, instantaneous equal rate of change of the position. Rate of change of the position. None of you learned at this stage, you have not learned yet calculus, you have not learned differentiation. No, pretty much any calculus not in the school curriculum in Australia to make it easier, more accessible to students. So later on, when you will learn, at least for doing Unit 1, 2, when you will start learning about calculus, we'll come back to that and we'll talk more about that. What does it mean, a rate of change? So, what are the units for speed or velocity, which you use in everyday life? Or, what else often used?
Kilometers per hour.
Kilometers per hour. What the relationship between kilometers per hour and meters per second? To get this, why we will use that calculation that will show, 1 kilometer, how many meters? 1,000 meters. 1 hour, how many seconds in 1 hour?
3,600.
3,600. So from here we get to convert from kilometers per hour into meters per second. We divide by 3.6 from meters per second into kilometers per hour. We times by 3.6. 3,600 divided by 1,000 is 3.6. That's where this number coming from. When we turn in between kilometers, meters, hours and seconds. So from kilometers per hour into meters per second, we divide by 3.6. From meters per second to kilometers per hour, we times by 3.6. So let's say if you're running at 10 meters per second, so you are close to the world record, what it will be in kilometers per hour?
36.
That will be equal 36 kilometers per hour. If you drive in the car, which you pretty soon all will start learning soon, and let's say you're driving with a speed which will not be permitted, but you, let's say even on freeway, you're speeding, driving 108 kilometers per hour. What it will be in meters per second? Use a calculator if you
30
can.
meters.
I'm pretty sure it's 30.
30. It is 30 meters per second.
Although, Mr. V, you should not drive 108 kilometers an hour.
You should know, yeah.
There is a road.
But I'm saying you're speeding, you're breaking the rules, and just give you an idea, in 1 second, remember, 1 second is a very short period of time. When you're driving at that speed, in 1 second you move 30 meters. It seems like 108 might be not good, but think 1 second, 30 meters. So you need to be careful, keep distance and not speeding if you don't want to get into the car. By the way, it's quite a lot of things we will be learning will be related to your future driving. Will hopefully that physics will help you to be later on a safer driver. But understanding the consequences of speeding and other things.
Mr. V,
No, yes.
do you know that just going 5 kilometers over the speed limit
It doubles the chance.
of a crash?
Yeah,
We will later on we will find out. We will be doing calculations how much increasing your speed increases your stopping distance. You are not ready yet to solve this problem, but next week you will be able to solve this type of problem. Yes.
When will the SACA for this be?
Next term,
Okay.
I cannot tell you exactly. I don't remember exactly.
No,
I
next
can
term.
tell you, but definitely next term.
I'm going to stay on an hour every day of term four.
I'm not.
Mr. V thoughts? Because then I'll be in
What
trouble.
is that?
Now,
What? Like 4 weeks?
so what the relationship, how we can express mathematically with the formula? That V equal S divided by T. Speed equal distance over time.
That's so confusing.
Distance over time. But now, let's consider next example.
Is that for speed or velocity?
That is distance. As we use it for distance, we will use it for speed or velocity.
Distance speed D.
Yeah, what's
Like I love D.
What is used in the physics textbooks and using letter S because they traditionally used for that. Now,
Because I'm going to get instant speed.
let's consider next situation. We're coming to the physics lesson, the bell rang, coming late, and we have two students. And this is the door of the classroom here. And we have one student, let's say Raf is at 20 meters when bell rang. And we have Eli is at 30 meters
Horrible student.
at when the bell rang. But Eli started running and running at 5 meters per second,
Let's wrap it up.
and Raf, not in a hurry, keep walking at let's say 2 meters per second.
I think one is more accurate.
Question is, who will get into the class early? Now, how to approach this type of problems? To do this, we need to introduce so-called equation of the motion. Equation
Just do.
of the motion, which will relate position. We will use x for position. X we will use for position. We will know how position relates to time. When we get this equation, it will be this equation of the motion that will give us position at any given time. And to apply this, first we need to decide, when we say position, we need to choose where will be zero, where we'll take a zero, otherwise we cannot measure. Position measured from somewhere. So let's say here is a zero. So what is at time equals zero? What is the position? What is the x1? We choose zero here.
Zero.
Zero. Position is zero. What is position of this student at time
10.
10? Because it's zero, so it's 10. Now, equation of the motion for the first student, x will be equal, equation of the motion will be initial position plus vt. Plus vt. Because from this formula you can see distance equals speed times time. So that will be how will be distance changing. Applying this case, we will have x0 is 0, v is 5, so position will be 5t. At any given time, position will be 5t. What will be position of the second student? First, initially 10 plus 2t. So that will be position, how position of the second student change over the time. And position of the classroom door is 30. Yes?
How come x2 is 10 again?
Because initially at time equals 0, initially this student is, as you can see, if this is 30, this is 20, this student is 10 meters ahead. So initial position time equals 0 is 10 meters. So let's find how long it will take of each student to get to the classroom. Because what should be their position when they get to the classroom? 30. So we have 5t equals 30, obviously it will be 6 seconds. Now we have 10 plus 2t equals 30. From here, t will be equal 10 seconds. So this student will arrive 4 seconds earlier than the second student.
Unlucky, right?
Yes?
I have a question. So if it says x equals x0 plus vt is 5t, what happened? Like I understand what happened to x initially.
What is the initial position of this student?
Oh, 0.
Zero.
Right. And then 10 plus
Now, let's consider another example. Let's say after the holidays, students coming to school, and Leo and Rob get excited. They have not seen each other for the whole holidays, and they are seeing each other at 100 meters away. And they start moving, so at time equals 0, that's where they are. And they start moving. Leo is still recovering after his injury, so he is moving slowly. Let's say 2 meters per second. and running at 3 meters per second. Question is where they will meet. To solve this question, we need again apply equations of the motion. First, we will take 0. We can take 0 either here or here. Let's take on the left. By the way, in physics, we don't have always take x direction of the axis from left to right. We are free to choose direction of the axis as it will be convenient. From right to left, up, down, and we can, even at the angle, we will see later on when we will be dealing with the forces, we will see such examples. Yes?
What does T equals it? Like,
T? T is a time. So initially, T equals that initial time, yes.
So to work it out, would you not just make it so that the position x is...
We need to write now equation of the motion of this student x1. Initial position with equation of the motion is x0 plus vt. By the way, we're looking at the moment, we're looking only with the motion with the constant velocity. When there is velocity not changing, no acceleration. Not acceleration, I'll know a little bit later on. So equation of the motion of the first student, initial position 0, will be 3t. What is the initial, and we choose to the right as positive. They will take 0 and choose direction to the right as positive. So what the initial position of the second student?
100 plus 2t.
Is it correct?
Minus.
Minus. Why it will be minus?
They're going the
It's going with the
direction.
negative direction.
Because we choose positive direction that way. And student moving in the opposite way. Talking about velocity, we always need to take direction in the account. And what will happen when they meet? What will happen to their position?
3t.
It will be same position. Their position will be the same. So we'll have 3t equal 100 minus 2t. From here we get 5t equals 100. So it takes 20 seconds to get to meet each other. And distance that first student will travel 3 times 20, 60, so they will meet at 60 meters from the position of the first student. Now, challenging question.
Wait, but if it is like, oh, okay, yeah,
This student will move 60 meters,
yeah.
this will move 40. Now, challenging question. Challenging question. Let's say distance from Melbourne to Bendigo, let's say 300 kilometers. So we have S equal 300 kilometers. And you drive in a car from Melbourne to Bendigo and then back. On the way to the Bendigo, there was a lot of traffic, and so you were driving at 180 kilometers per hour.
Isn't that so fast?
And I'm saying there was a lot of traffic on the road. On the way back, there was much less traffic. It was 100, so you would drive with the allowed speed on the freeway, not speeding, driving at 100 kilometers per hour. Question is, what will be your average speed? No, first, what will be your average velocity over the whole journey?
0.
0, because you will return the initial. So what will be your average speed?
90.
No, because
The traffic for
time
That's-
driving
that-
for longer time than maybe.
Yes, excellent. That's a typical answer, 90. Let's to find the average speed, we need to divide total distance over the total time. Total distance, what the total distance? 600. 300 there and 300 back. Time. How long it will take to get there? How we find in time? If you know distance and speed.
300 over 80.
We're dividing the distance over speed. That's time there. What are the time backwards? 300 divided by 100, distance over speed. What the total time? What will be the total time? We need to add them together. This is a time one way, this is a time backwards. Let's add them together so we have 300 over 80 plus 300 over 100. So now let's simplify, cancel the 0, bring to common denominator, which will be between 8 and 10 will be 40. So times this by 5, 600, times by 550, this we times by plus 120 over 40, and bring it to the common denominator, equal 600 times 40 divided by 270. Okay, use your calculators. You can cancel 1 0.
Just do a.
Can't you do 300?
Could you also just do
plus
300 over 80 and then plus 300 over 100? Like, couldn't you just also like figure this both sides?
Yeah, you can calculate. Huh?
88.88.
So it will be 88.9 kilometers per hour. So it's not 90, because as was excellent observation, it will be different time moving with the different speeds. So it's finding average, speed, we need to divide total distance over total time. Okay, that will be all for today. We'll start working on the next lesson.
This boy's got master